Okay, so let's look at 1.9, solving absolute value equations and inequalities. So the first example we have is solving absolute value equations. So what I want you to focus on is that the absolute value of any constant is the same as saying x equals a plus or minus version of that constant. So in this example here, we have the absolute value of 4x plus 7 equals 9, which means I need to write it as 4x plus 7 equals 9, and I need to write it as 4x plus 7 equals negative 9. So this becomes just solving an equation. Subtract 7 on both sides, I get 4x equals 2. Divide by 4 on both sides, I get x to equal a half. So there's one solution. Same over here, I'm going to subtract 7 from both sides. So I get 4x equals negative 16. Divide by 4 on both sides, that means that x equals 4. Those are my two solutions. Example 2 says solve the equation. Well, first I want to make sure that I have everything that's an absolute value on one side and everything that's a constant on the other. So I'm going to go ahead and subtract 20 on both sides. Cancel. I get the absolute value of 2x minus 4 equals negative 5. Well, there's no way that an absolute value could equal negative 5. So we say this has no solution. Write a little note off here. Absolute values cannot equal a negative number. The information there. Okay, let's look at example 3. Solve the inequality, express the solution using interval notation, and graph the solution set. So again, first I want to make sure that I have everything that's a constant on one side and my absolute value on the other. So I'm going to subtract 5 on both sides. I'll get 7, the absolute value of x plus 2, is greater than negative 1. Then I'm going to divide by 7 on both sides, and I get the absolute value of x plus 2 is greater than negative 1 over 7. Well, any value that you put in for x is going to make the absolute value be positive. So any number that I put in for x is going to have to be, that whole solution portion is going to have to be greater than negative 1/7 because all absolute values have to be greater than a negative or cannot be negatives. So a little note off here is that all absolute values will be greater than a negative number. So when writing this in scientific, or sorry, not scientific notation, in interval notation, I would just say that it's all real numbers, negative infinity to positive infinity. When I put this on a graph, because it also tells me to graph the solution set, I would just graph it as this, and I'd put 0 in the middle. I'm just going to put some little arrows off to the side because it's anything negative infinity or positive infinity. It's all real numbers that could be for x. So some information about number 4. So if you have the absolute value of something and it's greater, then that means that you have an or problem. If you have the absolute value of something and it's less than, then you have an and problem. And we'll talk about what that means as we go through this problem. Okay, so solve the inequality, express the solution using interval notation, and graph the solution set. So again, first I want to start by getting all of my inequalities, all of my absolute values on one side of the inequality and all my constants on the other. So I'm going to go ahead and subtract 8 from both sides. So those cancel. I get negative. The absolute value of 2x minus 1 is greater than or equal to negative 2. Then I'm going to go ahead and divide by a negative 1. But remember, when you divide by a negative, this sign has to change. So that means you get the absolute value of 2x minus 1 is less than or equal to 2. So from this point, I notice here that this is a statement of and. So this is type of an and problem. or equal to, it doesn't matter, it's still going to be and. So when doing this, I have to set 2x minus 1 if it's less than or equal to 2, and I have 2x minus 1 has to be greater than or equal to negative 2. And even if this was an OR problem, guys, you'd still have to flip that second inequality here to be its opposite. So when solving this, I'm going to go ahead and add 1 to both sides. So I get 2x is less than or equal to 3. Divide by 2. So x is going to be less than or equal to 3 over 2. That's my first one. Then I'm going to add 1 to both sides. So I get 2x is greater than or equal to negative 1. Then I'm going to go ahead and divide by 2 on both sides. So I get x is greater than or equal to negative 1/2. So when graphing this and writing it in interval notation, I'm going to go ahead and graph this one in red and this one in green so we can see. So if I graph these, I have negative 1/2 and then 3/2. So when plotting this point, I know that for 3/2, I'm going to include 3/2. Oops, sorry, wrong one. So at 3/2, I'm going to include it. And then I also know that it has to be everything less than 3/2. So I'm just going to draw that line there. Then I'm going to look at the negative 1/2. Well, I know I'm going to include that one because it's or equal to, and I have to have anything that's greater than that. So if you notice here, it's everything that is meeting wherever it meets, which is right here. That tells me that in my graph, go ahead and do that one again. In my graph here, it should look like this for my final answer. Change colors. It'll be negative 1/2, 3/2, and it'll include here looking like this, which means my interval notation would read negative 1/2, comma, 3/2 with a hard bracket. All right, guys, this is literally everything that you're going to be doing. Check the board, check Schoology's updates for any homework that you may have. Just a reminder, Tuesday we will review for our test on Wednesday. It'll be your first test that you take for Chapter 1 and just for College Algebra B. See you guys. If you have questions, please don't hesitate to come ask during a tutorial or after school or even at the end of the class period.